you. I'm Todd McDowell. I'm the Director of Data Center Switching Product Management at Aruba. I'll be joined here with Yash partway through, and we're going to go through, as Tom mentioned, some of the new things we're bringing to data center fabrics and what we call kind of the fourth generation of data center networking fabrics. I'll give a little bit of preamble here as we build into it. So I think we're moving away, as I think a lot of you know, away from your traditional, data centers, which are kind of singular locations, and kind of spreading things out to what we call, centers of data. Whether this be, public cloud, an edge network, colos, various different attributes. But there's a huge explosion of data out there, and there's a big push to have these centers of data closer to where the data is entering into the network. And so this introduces, some opportunities, introduces some complexity, and we've got some solutions here that try and solve that problem. We try and lead into this with, kind of the generations of data center. I won't bore everybody with the history lessons of what happened in the 90s and the 2000s. The real neat stuff started in the kind of 2010s. About every 10 years, something new pops up. In 2010, we moved away from big chassis and kind of went to a spine leaf architecture where, we're really scaling up and scaling out with 1RU boxes. The innovation of, kind of underlay and overlays, being able to run kind of separate but parallel networks on top of this infrastructure. And then the kind of applications that were in there started to change. So very microservices based. And the way the networks were constructed really didn't lend itself well to securing the data centers based on how the other infrastructures were in place in that data center, essentially bolt-ons at the end of a row. And so all of the data had to go through kind of unnatural acts to get to the service chaining treatment there. So in 2021, we announced a product which started shipping in 2022. As was mentioned, this was in conjunction with our partner Pensando, now AMD Pensando, and ushered in a new category of product called the distributed services switch, or the distributed services architecture, which really ushered in the fourth generation of these data center networking fabrics. What this does, and I'll try and illustrate it on an upcoming slide here, but really to show you what it is, it looks like your typical top of rack switch, but inside is kind of the secret. We've integrated in 800 gig of stateful layer 4 through 7 packet processing. And we can get to a whole bunch of additional services, such as firewall, DDoS, telemetry, and some new stuff that we're talking about here today that Yash will go over and show a demo of as well. And it's a fully programmable pipeline, so there's lots of additional capability we can add in there over time directly into the switch through software, instead of adding in, additional appliances, dedicated to a singular function in the network. So today, if you look at how, most generations of data centers are constructed, or at least the third generation, you've got your racks full of compute, and over there you've got a services leaf which has all of your bolt-on appliances, firewall, load balancers, everything else. And because all of the applications are microservices based, there's an explosion in this east-west traffic flow. So as you try and secure this traffic, everything has to hairpin over to this services leaf. So it's really inefficient usage of this very elegant, scale up, scale out spine leaf architecture that was designed. And you're kind of not taking advantage of it. You're adding in all kinds of multiple hops. You're introducing a lot of additional latency, through the leaf switch, through the spine switch. You're essentially traversing it 2 different times when you should only have to traverse it a single time. And then all the induced latency in that services leaf as well. So very inefficient, very expensive, very complex. So as we move to this fourth generation of data center fabrics, pinned by the distributed services switch, the CX10000, what we've done is we've taken a lot of these services that reside historically in this services leaf, and we've pushed them across directly into the top of rack. So we've actually moved those services and combined them into the logical place in the network. You already need a leaf switch within every rack, so why not logically move these services into that top of rack switch? Essentially what we're doing is providing a firewall, if you will, behind every port on that switch. So we give you 800 gig of stateful services directly within that rack. So it makes it a very seamless transition of securing that workload and keeping it, either directly in the rack or just a single hop away if it has to traverse to another rack. So greatly improving the latency of the overall network. The complexity goes down greatly. And if you heard from DXC today, they're a lead customer, and some of the things we're deploying, we've modeled out about a 1/3 total cost of ownership in most scenarios. They put on stage that they're seeing an 83% decrease in cost versus how they're doing things today in kind of that traditional third generation model. So huge improvements in TCO just by putting these services directly into the switch that you already have in that network. What we're doing, this isn't really the new news necessarily, but it's worth a recap because it is doing things, greatly different than any other vendors doing today.
Yes, services stay in that service.
So today we're focused primarily on what we view as the bigger problem in that data center, and that's securing that east-west traffic flow. So we've migrated that east-west firewalling capability into the top of rack. You'll keep a firewall in there for north-south, kind of your perimeter security. And today you'll probably keep load balancing in there as well. But as Yash will get up and talk about, we're moving things like IPsec and NAT directly into that top of rack switch too, and adding those capabilities in there. And because it's fully programmable, I won't say the sky's the limit, but we have a lot of flexibility to continue to pick and choose the right bits of services out of that services leaf and integrate them directly into that top of rack closer to the workload. So you're not displacing everything in there, but you're making a more efficient usage of what is still in there. And as you scale out each of these racks, if you grow capacity, putting these services directly into that top of rack switch lets you scale linearly instead of having to go in step functions of putting in, say, a new firewall every time you exceed the capacity and having a large increase in cost. You're just small chunks of, kind of linear progression, adding that scaling capability.
Thank you, Todd. That was really a great summary. As you guys know, campus switching, that's nothing but your access point or the users where they connect. We are trying to bring the security. Similar to that, the maximum amount of data stays in data center. That's called as the workloads. What are those workloads? Just if you think about, it's all your data, your user credentials, not only user credentials, if you are looking at a financial sector, all your, whatever the bank transaction you do, everything stays on the workload. Maybe a SAP application or your HR applications, everything is sitting there as a container infra or the VMs, right? These VMs have stayed for a long time, and each one of them carried a lot of this traffic to that east-west, what Todd talked about, to a centralized appliances. That's where the 100 gig or a 200 gig of uplink traffic in data center, it is not 1 gig, 2 gig, or 3 gig of traffic uplink. 100 gigs of traffic is going to the centralized firewall, and you're getting that firewall appliances doing the TCP, UDP filtering, and then it is getting back to your workload. And if you have a one VM, as you know, whenever something sits on a one hypervisor, most of you deploy the overall VMs on the same VLAN. One may be a Microsoft Hyper-V, other might be running Linux. If it has a small software error on the one of the VLAN, that can infect the overall hypervisor because they're all running on the same VLAN. That's what it's called as micro-segmentation. In the campus, we have already solved it so well in Aruba. Same VLAN, you cannot talk to each other. That's called as a micro-segmentation. In the similar approach, working with Pensando AMD, we are bringing this on a workload. That's what Todd spoke. If you remember, that's what we are doing on a micro-segmentation. That means within the workload on a same VLAN, I can make sure they're not talking to each other or they can talk to each other. I can allow the whatever it is happening on the security compliance issues, which is stays on one of the VM. I can quarantine that VM, move that VM to a right place. That means if I want that Hyper-V to be updated to the latest, I can do that. That's a huge impact in the data center than in campus because your workloads are staying on this one. That we solved it. The second problem, which was very cleanly explained by Todd, was agents. Today, to do some of this portion of the microsegmentation, there are some companies which are working, they always give you an agent. That means they are going to occupy your 30% of your hypervisor bandwidth. The hypervisor is not doing compute, it is not doing storage. What it is doing, it is sending all the telemetry sitting on these hypervisors to that centralized appliances. And that's also now solved with Aruba AOSCX 10,000. That's very clean explained in the previous. That's both the problems are solved with one, which is known as the same top of the rack switch can do east-west firewall, stateful firewall of 800 gig sitting on a top of the rack switch. It comes with 1/3 the cost. Really, we have seen that Antonio was talking about it, and also DXC customer went on stage and spoke about it. What is the next problem we are trying to solve is the IPsec. IPsec has evolved for a longer duration. Before I just go into the details of it, to just level set, what is IPsec? Any protocol plus that sec is nothing but confidentiality, integrity, and authentication. Any sec, whether it's a MACsec, IPsec, tunnel sec, many people call it. Whenever you see that sec is nothing but these are the 3 checks every protocol go through. IP is nothing but your layer 3. VPN is been there for a longer time in the industry. There are different types of VPN. Consider a L2 VPN or a L3 VPN. Those are all leased connections. Lease means Xconnect, VPLS. Those kind of connections you run from data center to data center. And those lease connections are good, but they are very, very costly, very, very highly expensive, because whether you're using or not, you're paying for that pipe. So is there any better way to solve that one? That's where the introduction of IPsec came in, where you can make use of the normal internet. So you use the normal internet, whoever the ISP is, and on that you build an encrypted tunnel. The problem with this connecting the data center is the firewall appliances can do this. The only challenge is, look at this one. Where is your workload? They're all sitting on a rack of each of this. You're taking the whole traffic of 100 gig and giving it to the firewall. That means the administrator has to learn the operating system of a switch. He has to manage the workload, and also he has to understand that other vendors. Not only that one, he also need to understand many appliances, because they are all doing a centralized ways, and then they have to teach this one. Though there is 100 gig, but IPsec tunnels which they have given only provision today is some routers also do this IPsec with 1 gig, 2 gig, but somehow these firewall vendors have come to a game of 10 gig to 40 gig. But what to do? The uplinks of the data centers are not 40 gig, they are 100 gig uplinks I'm talking about, not the one which connects to your hypervisors. They are all 25 gig. So that's where you get into a problem of bottleneck. That means you have a full pipeline of traffic, but that's getting into a bottleneck. How do we solve this? That's where Aruba distributed services platform comes in handy. This is really a magic. It's not really a magic. 2 companies are working for this. Let me go back and show you this one. So that's where we come in to solve this problem. What is the problem we are trying to solve? On the same border leaf switch where you want to connect 2 data center, let's consider I want to connect Bangalore HPE office to the Roseville. So I have 2 data centers I want to connect. I can use the border leaf switch with all the capabilities of the security plus NAT functionality, plus we do the IPsec. Remember, even today in the networking deployment, these 3 things what I said are not done in a right order. NAT is done sometime after the IPsec, which is really a problem. So that's where I would really like to thank AMD Pensando product management team and also Todd McDowell team. Basically, they've done an awesome job of putting this in the right place. That's where customers can get full benefit of it. The best benefit here is do the first security services near to the workload. Once the security policies are applied, go into NAT, then do the IPsec. That's a right way of executing this one, not doing in any order. If you do it in any other order, you are going to bring more complexity in the network, not going to solve any type of problem, right? And as I think Tom introduced, the Pensando team, NPLS, they really know all of this and how to solve this. And with working with both the teams, we have solved it really good. So remember this one. This is if you are only using, let's consider there is an hospital environment, you are sending only X-ray data, one directional. It's a 400 gig IPsec. That's what the encryption only you can make use of. But if you are using a duplex, let's consider both are talking. It is 200 gig IPsec. That means I'm doing on the same ELBA encryption as well as decryption, then it is 200 gig. Okay? Does it make sense? That's what we are introducing as part of this release, which is coming in 3 months. Okay? NAT, 500K NAT rules can be applied on a one CX switch, border leaf switch, CX 10,000. very powerful. If you have been in the industry, you will know these rules are not so easy to provision on the ASIC. So let's go and check the little bit of demo on this one. So what I'm trying to do is I'm trying to connect two data center, and both are talking. As I was telling, it is a demo of two data center which are using the full duplex capacity, not the 400 gig. It's not a one directional. It's not just we are doing a data backup. We are talking about the directional. There is a very good concept called PDT. I would just like to take a 1 minute to explain that one. What is PDT? Policy distribution target. As you know, on CX 10,000, as I briefed, there are three features which are very critical: security policy, NAT, and IPsec. We don't want to distribute all of this on every leaf of the switch, right? For some, I want to have only security policy. For some, I can only use NAT. For some, I don't want to use IPsec. So I can distribute that one. This is a very good concept. You can map that to your PDT in your data center. That's called the policy distribution target. That's a new introduction on the ASCX or the overall technology wise. Just I want to brief on that one. I really like this one. It's a really a good concept. Once you configure the PDT, that means you know where your targets are. That means which is the data center I want to form a site-to-site communication. The next step is, as the PDT is done, both the data center PDTs are configured. The next step is go and configure the IPsec. The configuration of IPsec is exactly same as what we did in the security policies. So IPsec, if you know, what is the first thing we'll do is to create the policy name and give the target where you want to apply the policy. Let's consider the site one, that's a data center one, you want to apply that policy. IPsec, as I was briefing, any sec has three phases: confidentiality, integrity, and authentication. In the IPsec, there are two phases which happens. One is called the initiator phase. That means I exchange my keys with the key V1 or a V2. V2 is very important protocol. It has come up with a long way compared to the V1. But if you have a customer's other site is only V1 capable, we can do V1 also. So that's what you do first an initiator, and you configure the pre-shared key. If you are thinking about are we supporting RSA, that's our future. That's a roadmap. But we are starting with the pre-shared key. Once we are done, there is one algorithm I just want to mention because probably that scientist has worked very hard on this IPsec called Diffie-Hellman algorithm. So basically, you are doing the cryptography on those payload. So that's what we are going to use, and both the data centers are now configured. You can see the second data center is configuring. This data center is a responder. The data center one is the initiator. Once we are done, the next thing is we want to attach this IPsec policy. The third step is attaching to the VRF. Is exactly same as what we have done in the security policy. Just go into the one, see the order how we have kept this one. This is a beautiful order if you ask me. That's what I would really like to thank. One is the security policy first, and then the NAT, and then you go into the configuring the IPsec. And you apply that one on both the data center, or you want to apply on only one is single data center, that's also absolutely fine. Maybe the other side is Palo Alto, or it might be some other vendor who is doing an IPsec. We can terminate that one. Let's go and check this one. That's all. Configuration wise, just a 3-step. Is the IPsec tunnel is ready? Yes. That's where you get the 200 gig IPsec tunnel end to end, both the directional. The tunnel is up. You might be thinking, what's happening with these drops? IPsec tunnel, are you dropping? As I said, this is a pre-GA code. We have 3 months to work on this one. That's where you see these drops. We are working hard. By August is the release, this one. So as you see now, this is what the TX throughput. That means it's almost there near to the 200, and this is the RX. And we have this demo also in the innovation zone live. You can walk us. You can come over there and see all of that. Is it only one tunnel we support? Every tunnel cost for you in the current environment. That means if you're going from 10 to 20, they charge you for one more license. IPsec is very costly. In that way also, though it comes up with not with the L2 VPN or L3 VPN, even though it uses the internet, but to provide that services on the firewall vendors today, they charge you for every IPsec tunnels. We support, as we are testing, 510 tunnels are done. The goal is to support 1K by August. So we support all type of encryption algorithms. As you see, AES is nothing but encryption, advanced encryption security. That's what we put on the AES. And this is what you see on the each parameters of the traffic. And just to see on the what happens on the payload, you can see that one. It's a ESP, encapsulated security payload. That's the payload. That means we are encapsulating the payload. That means your complete workload and also all the control plane. right? Exchange between whatever it happens between the data center, that is also secure. So with that, let me go back and show you something new more than this. What about then the telemetry? Current environment of the telemetry is very, very cumbersome. Why I'm saying this cumbersome is because these platforms are not built today. The today is all about REST API. I don't know, last 5 years back, were there any REST API? So, but today it's all REST API, fully programmable. That's what we are looking for. The current platforms are not capable for such kind of a telemetry. Apart from that, when we build this L4 to L7, giving that visibility to right industry best vendors is very important. And that's what I'm going to demonstrate to you now with the CX10000. Not only you can access the L2, L3 with the REST API, that's always available on a database, as you saw in my other tech field day discussion, we already discussed, but security policies also have all the REST APIs for you from the Pensando. So you can have the REST API and get all the flow data to your best industry best integrations like Splunk or Elk or any of those things. Let us see for today a live demo of how a security ops guy can make use of these data of TCP. Let's consider I have 2 servers. During the Christmas time, many people are ordering more gift, but the server capacity has to grow. So how can I provision those TCP UDP connection? Can I look at those things and grow that stack? That's what we are going to see in next 1 or 2 minutes. I'm going to keep it like short for 1 or 2 minutes and then leave you for questions. This is for a SecApps. Directly telemetry is coming to ELK. It's nothing but elastic ELK integration. You can see here you have all the types of rules you can apply on this one. For a SecOps guy, let's consider he wants to understand some kind of allow or deny. He can permit them, he can stop them. He wants a Kafka traffic, he can stop that one. He wants a web traffic, he can, whatever he wants to do, he can do that one. He can just allow or deny. He can watch that one. Okay, is my compute is capable of taking all the HTTPS connections or not? Or I want to limit the TCP connection for 100 for this month. He can do that one. He can limit the UDP connection. All of that is possible using the ALK integration. You can also see what are the talkers on the CX10000. So this is what I was talking about. Even I got a lot of feedback from Todd on this one. He was talking about how do we allow this event, how an admin can make use of this one. Let's consider I have allowed everything, but you want to select something and you want to say, hey, you know what? I want only these port traffic. I don't want many port traffic. Let's consider only I want some, let's go and check this one. I want to allow DB traffic only, right? Now you can see the traffic got reduced. Are you able to see that one? Earlier traffic was different. Now I can deny some more Kafka. So you can see some more traffic is reduced. So I can control my compute. I can control my storage traffic depending on what I have the capacity on which month, which is a very important tooling aspects, which is given by AMD Pensando in integration with AOS CX10000. This is a huge capacity which we can make use of on IPsec, NAT, as well as security policy. We are bringing networking plus security near to the huge workloads in your data center on the top of the rack switch. You don't have to go through all those services to the service leaf, whatever they used to call separate rack, which is a service leaf rack. Now you don't have to go to traverse till there, wasting the fabric bandwidth. And also remember, people are talking about next generation of our self-sustainability. You're taking all the fabric, 100 gig fabric, you're burning all of that ASIC, everything, right? On the spine layer, leaf layer, everything. That means you're burning more power in the data center. If you do it near to the workload, you can solve a lot more problem and also achieve a lot of sustainability.
Commented on saving power and sustainability. Do you guys have numbers into how much power is actually being saved?
As it is introduced only last year, we are getting the customers. Once we have real data we want to share, maybe probably by next tech field day next year, we should have some good data on how much power saving we are able to achieve with CX10000. It's coming from directly from the customers, right? It's now we are saying 1/3 the cost. It is definitely improving. Customers are speaking about Todd has a lot of customer data which we can also go through. So customers are telling us saying that there is a cost reduction, what they can see, because they are not deploying the number of appliances. And also as a network engineer, it's more cumbersome to understand all those appliances. Every day I have to learn, and anything happens, where is the whom to call? There are 10 people to call, right? Because there are so many agents running on my workload. Now it's not that way. It's just one top of the rack switch, near to the workload, how you are there with the DHCP connection, anything happens in the campus, how you debug. Same way I can debug on the workload now, right? So that's a kind of an idea, and this is a revolutionary. Last 2 years we are there on this journey, and we don't see any competition on this, right?
Yeah, so I guess in absence of other questions, just to kind of wrap it up, and we can also hit more questions, but kind of taking it home, as you kind of heard in the previous session, the CX, one of the values the CX product line brings to the table is it's the same operating system all the way from the branch, the campus to the data center, which is somewhat unique in the industry. And then layering on top of that the distributed services architecture that we just talked about today, and some of those benefits we can bring to the table. And then the wrapper above everything there is the orchestration of these data center fabrics using Aruba Fabric Composer to kind of automate and orchestrate these fabrics. A very elegant tool to configure all the policies, the IPsec, the NAT. Just makes it very simple and clean to do that. And I think just going back to the question you had about do we have a quantification yet of the power number? So today, no, we do have a tool called the Aruba Value Advisor, which quantifies a number of elements as far as which types of devices you're displacing, but more from a capital and operational expense perspective. We can look to leverage in things like power calculation and electricity costs and things like that as an improvement to those tools, and it basically presents a full presentation of all the value that it brings.
Question that there are advantages and disadvantages when you distribute versus centralize something, right? And one of the advantages of centralizing it is the manageability, your growth, your scaling, things like that. But distributed, you're managing lots of different things, and one could potentially become, problematic from a performance perspective. So how are you layering something on top of this to kind of manage the disadvantages of distribution?
Yeah, so I think as you stated, there's always a pendulum that kind of swings between centralized and distributed. From the benefits that we bring here, one of the first and foremost is just the cost, the capital acquisition. And then there's a lot of operational savings as well, integrating it directly into the top of rack switch. The Aruba Fabric Composer, I'm pointing to the gentleman who manages the product in the back. This is the tool that really orchestrates a lot of that, and it has kind of multiple role-based access. So even though you might do something today on the firewall and something else on the switch, the Fabric Composer tool allows you to use that tool for both of those. It's not going to displace all of the the perimeter security that you have in the firewall today, but we think based on the operational savings, the CapEx savings, it's 1/3 of the total cost of ownership of a competing similar solution, whether it's a centralized based or distributed agent based one. We think that really is kind of moving the needle for most customers. And there are some that say, hey, I just like to manage my firewalls through my existing firewall tool. But over time, as this distributed services architecture takes root, it'll take a number of years before isolated the NetOps team and the SecOps team kind of understand that there's benefits to be gained. I think the model will really start to move forward in the industry.
One additional question. I'm not really a compliance person, but is there compliance issues? Because, if someone's really needs to meet regulatory compliance by distributing it like this, does this increase their workload because now they have to ensure compliance across a much wider platform than they used to when it was more centralized?
Yeah, so I think I don't have the direct answer there. There's certainly tools out there that do firewall rule compliancy and things like that we are not currently integrated with. We have a lot of capabilities through telemetry being one of them, but a lot of the data that comes from the distributed services switch can be ingested, and we do have some integration like with Guardicore, where we can do application dependency mapping, where they can ingest the telemetry information from the switch and output some rules that should be implemented from a firewall perspective. Then the next step would be looking at compliancy tools to see how we can integrate that into the overall compliancy of the rules.